My name is Yasin, and I have Ben with me here from IHS Markit presenting. One of us is from Bulgaria, the other one is British. I will let you guess who is from where. Okay, what we have prepared today, I will give you a quick intro on the vision with NSX that we have, and after that I will hand over to Ben to explain what they are doing and how they use NSX and VRA. And after that I will go deeper to how and what we can use to automate NSX and in particular NSX T. So out of curiosity, how many of you are doing something with NSX? Some automation or something? Okay. Oh, everyone. Okay. Okay, so this is focused mainly on NSX T, but many things are valid for NSX for vSphere as well. Okay, so even from last VMware, maybe you have seen that our vision is virtual cloud network, and so the vision is to provide connectivity and security for any workload everywhere. And how we do this? We do this like we provide this completely in software. So you can have your workload protected and connected from everywhere, only if your networking solution is software-based. And in order to achieve that, we have a huge portfolio of products. NSX data center, so it provides this connectivity for your data center. We have also NSX Cloud that provides connectivity for Azure native workload or AWS. We have also App Defense that inspects the behavior of the applications and provides security based on this behavior. Recently we acquired VeloCloud, and we have NSX SD-WAN by VeloCloud, and we have NSX Hybrid Connect to provide connectivity between all these solutions. And of course, on top of it, we have solutions for network monitoring and automation like Network Insight and vRealize automation. And yeah, this is where we will be focusing in this session for NSX Data Center and partially NSX Cloud.
All right, thanks, Yasin.
Thanks.
Okay. So I'm Ben Tanner. I head up what we call cloud enablement at IHS Markit, which is a combination of architecture, automation, a mixed bag of things. So I'm going to give you a fairly light touch overview of one of the sort of things that we're doing today with NSX. I'll give you a bit of an overview of who we are as a company, where we were, what the challenges we had were, how we're using, or where we need to try and get to as an organization, and then how we're using NSX and VRA to help us get there, and a little bit of thinking about what we can do next. So IHS Markit, we're a global information powerhouse, I suppose the best way to describe us. We bring information analytics and insights to over 50,000 customers around the world, over 80% of the global Fortune 500. I think the vast majority of the US banks, 94 of the largest 100 US corporates, all the G20 governments, the global investment banks, etc. So we've got a very wide array of customers in a large number of sectors, and it's all about information for us. So we collect data on sort of maritime shipping, process that, repackage it, sell it on. We do financial metrics. We have products like Engineering Workbench, where we have breakdowns on how the components of aircraft are put together. We actually publish the international standards for nuclear reactor boiler vessels. The big one that most people in the US knows is Carfax. Jane's Defense is also part of our organization. So broad portfolio of information-focused things. Global IT within the organization, it's not huge. There's only about 650 of us. We're supporting a user base of 17,000 users, 20,000 servers on-prem. I think we have about another 3,000 or 4,000 in AWS today as well. And those servers supporting 600 in-house developed applications. So we are fundamentally a software shop, although it's an information focus. And those servers are spread across 9 strategic and lots of little tactical data centers. About 15 petabytes of SAN storage across this environment as well. So it's a big estate. There's a lot of challenges around managing an environment like this. IT split into 4 major divisions. We have a team that's focused on supporting our product development groups. That's our CPDS team, classic corporate internal IT, synergies team, who are mainly focused on closing down as many of those data centers as they can, and our world architecture and engineering, who are future focused. So where are we trying to drive the organization to next? So as a company, or as an IT shop particularly, we found that we were not really meeting the business's needs. A lot of IT functions we delivered were automated, but there was no direct benefit outside of IT. The product teams couldn't directly consume them. And as a result, even with the automation we had, the global IT teams were still taking weeks or months to actually deliver things. We got an example of a sort of a project pipeline that we go through. Product teams say, we want to go and do something new. So talk to IT about it. We'd go and help them build a project plan, very iterative, very waterfall driven. We'd then start building the networks. We'd start laying down the servers. We'd then do the firewall rules. We'd then try and deploy the product. We'd then realize we'd missed firewall rules. We'd go backwards and forwards. It was a very transactional process. The cycle above was taking us anywhere between 2 to 4 months, even with automation. Most of the processes were automated in their own right. There was no overarching orchestration between them. So when we deployed a server, it didn't necessarily have the firewall ports it needed open. In fact, if we deployed a new VLAN, there was no guarantee we'd even be able to build a server because the network rules for the kickstart servers might not be there. So a lot of pain points around this. And it meant that when our development teams who were trying to develop in an agile way wanted to go and do things, work up a concept, do proof of concepts, do rapid iteration, it was just impossible for them. We had no way of reclaiming stuff when developers was done with it either. So we were left with a challenging scenario that saw a huge uptick in public cloud usage. So we sat back and we thought about where do we need to get to as an organization. So our Office of the CEO set a target of 80% of IHS Markit's products to be actually into the cloud or cloud enabled by 2021, which is quite a challenge, but we've got some ideas around that. It started off with changing the notion that cloud was a place. I think when we talked to a lot of our product teams, cloud was Amazon or it might have been Azure. And we sort of pushed back and we worked with them, and really it came back to cloud being a set of capabilities rather than a specific destination. And the idea now is that global IT now needs to develop the capabilities with our product teams to give them the agility they need to remain competitive. It's a very aggressive marketplace, so time to market really matters now. And this is where now we as IT are starting to work in partnership with our product teams to try and cloud enable their applications, which means developing new ways of working. Not every application is going to be cloud native. In fact, we think only about 20% of our applications actually end up cloud native, but the tools that we're developing don't just benefit the cloud native apps. I think it's also the classic legacy applications also benefit from them. As we approach this, we had a fairly well-defined set of architectural principles that we're trying to adhere to. I won't go into too much detail around these, but every data center we build, we're now trying to make sure it's an autonomous entity, so there's no ability for services of one data center to impact another. Iterative delivery. Classically, we as IT would take the ocean boiling approach. We won't release something to the product teams until it's absolutely perfect. We're now trying to transition to an iterative approach where we're talking about minimum viable products. Cloud native first, so let's look at leveraging proper cloud native technologies where we can, rather than forcing automation around our existing legacy estate. Avoid custom engagements. So this is we don't want to be building snowflakes. We want to be building a standard solution that we can rapidly deliver out to our product teams. Ubiquity of service. Anything we build one place, we need to be able to build everywhere. And then transparency. Again, it's how's the system performing, what's it costing, et cetera, et cetera. And then lastly, probably the most important one to some extent to the product teams is the self-service. It's the ability to put them back in the driving seat for their products. Everything we build now has to be as a service and has to be consumable either via the GUI or the APIs. So that's how we're starting to approach things. How are we using NSX and VRA to get there? The main thrust here is to take the wait states out of all of our IT processes. We don't want our product teams to be punching tickets. Every time that there's a transactional, I need a firewall rule opening. Where do you need it opening to? Blah, 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 blah. It goes back and forth and back and forth. it's unacceptable delays to the product teams, and it creates a bad perception of IT. So we're really trying to get wait states out of the IT process. Onboarding as a service, so as we bring up these new services, we want to have the onboarding of our product teams as quickly as possible. So again, everything we do becomes as a service. So once we get into things like server provisioning, it's an automated process. There's no more waiting around for this legacy process to sort of design and waterfall through until we get something out the other end. Product teams can now start to consume the service straight away via GUIs, via APIs. IT can drive it for them, they can drive it themselves. So we've got our 2 to 4 month build time down to sub 1 hour. And we're baking in things like the firewall rules by default. Here we go, secure by default. This is the key thing here. So every time we provision something through private cloud, it's secure by default. And we're using a metadata model to start driving that. But just, the initial birthright rules we stand servers up with aren't sufficient in and of themselves. We say, right, well, every Linux server has port 22 for SSH. Every Windows server has port 3389 for RDP, etc. But the product teams want to do more, and they want to be doing that as quickly as they possibly can. So, excuse me. Enter firewall as a service. And the idea here with firewall as a service is to leverage VRA and NSX T and the programmability in the API to start delivering an iteratively developed service offering for our product teams. Starting off very simply, we kind of created a list of known good rules. If you're a web server, it's okay to have port 80 open. If you're classed as a database server, you can have port 1433 or I've completely forgotten the Oracle port number, but yeah. So we can define these safe ports and tie them to tiers in our environment, and then we can start presenting that to the product teams through the VRA catalog, and then pushing them out into NSX and the DFW. And then, as you can see, we've sort of laid out an iterative delivery model for how we're going to start developing this. So standardized rules is the start of this process. When we define a port, we approve the port at definition time so that when the requests go in, there is no approval process anymore. It's good, off you go. The next thing we're then looking to try and achieve is, I've built my product in dev, I've defined some rules, or I've got some traffic flows going. I now want to propagate those between the environments. I want to take it from my QA environment, push it to my prod environment. So again, we're capturing the same default sets of rules, and pushing it between what we class as our intermediate and our secure environments. I'll talk a little bit more about that towards the end. So the idea would be, once I've defined and tested my rules in firewall as a service in my intermediate environment, I then take those, push them to my production environment. We automatically take care of transitioning IPs, etc., where necessary. Some of it's done in security tags, some of it I think is done manually with IPs still. But again, the workflows that we've built into VRA, VRO, and NSX take care of that piece for us. And then, as a slight future development here, we're starting to look at utilizing VRNI in our development environments to identify flows now, so we can actually start modeling the firewall as a service rules off of that. So if you look at it from a full product view, what we actually end up with is a fairly open development tier in our estates, and then as we go for our sort of intermediate or our QA or UAT tiers, things get locked down. And then we'd actually really want to present people with the ability to open firewalls in production. We only want to transition them from our UAT QA environments to production. So they've already proved out what their product needs. We know it's safe, we know it's secure. The next iteration, we're then looking at delivering north-south from private cloud. Again, we're taking a pre-approval approach here. The challenge we have is that the private cloud environments and our legacy brownfield environments are very separate. We'd like our products to talk through standardized sort of front doors through their web tiers. It's not always possible, but again, if it's a standardized port, there's no approval required. If they want to go off-piece, that's where we start introducing approval workflows again. Again, we want to try and avoid this, but this is where we go. The next stage, and this is something that we've been working on, a colleague of mine, Andrew, will be doing some more presentations around this later on this week, but it's then what we call the east-west rules between the different products within private cloud. So this is where we start aligning our network security groups between the products. Again, all driven out of the VRA APIs at the moment. We're having to do a lot of custom Python coding. Annoyingly, or fantastically, I think VRA 7.5's now introduced the APIs for NSX T. So a lot of the work that we've done manually, as we were sort of jumping into this product, is now going to start being baked into NSX T. But there's still some areas I'll touch on where we're going to have to keep pushing forward with custom code for a while, which is really in this piece here. So out the box, NSX T does not, again, if we go back to the concept we have of data center autonomy, we have separate NSX managers in each data center. They don't know about each other. So we have to have a way of synchronizing our security policies between them. So we've worked with the NSX business unit to effectively build an NSX security policy synchronization tool. A lot of Python, a lot of VRA work that's gone into this, and then we're now working with them to effectively help shape the definitive way of doing this going forwards, I think.
Yeah.
So hopefully if you're looking at NSX T, you'll see on the roadmap in the near future that policy synchronization will start coming out as a standard service. And again, this is how we'll start propagating our rules between the products in different data centers. And again, pre-approval for standard ports. The challenge we have next is, I'm going to skip the first one there and talk about the second bullet point. The challenge we want to start dealing with is how do we deal with tickets, or non-standard ports without going to tickets. So this is where we're looking at looping out from VRA to a governance engine. Algo second tooth into the classic ones that people know about here. We're hoping that, and we're going to talk to the BU a bit more about this, that the VRNI is going to start growing in that direction as well. So that you don't just have your known safe ports, you have something that understands the risk of a rule that you want to add across your environment and can make an automated judgment for you. So that's the next sort of area we want to start investigating. We want to start moving away from the concept of dev, QA, UAT production to almost like serviced environments. Dev, QA, UAT product useful for our product teams, they're not so useful for IT. What we now need to do is start talking about describing our environments. Unsecured, intermediate, secured, etc. Then the next piece for us really is, after firewall as a service, it's load balancing as a service. Again, we're waiting for some of the capabilities in NSX T to really reach the point where this works for us, and we can maybe look at what we're doing with F5 and have some serious thoughts about its longevity. But again, load balancing as a service. Again, the approach, iterative, start with the real simple basic elements and then just build it up until we've got a completely capable service offering for the product teams. And then the next piece will be integration with VMC, but we'll probably talk about that next year, I hope. Yeah. Over to you, sir.
Yeah, thank you, Ben. And yeah, so from now on it will get a bit deeper technical, so you may have some headache, but in order to keep your interest till the end, the last section I will talk about VRA 7.5, which we announced the general availability today. So you may be the first who will see something for this version of the product. And Ben mentioned about the session that my colleague Andrew and his colleague Andrew have together on Wednesday. It goes deeper how exactly they do everything that Ben showed us. And I recommend you to go and see this session because they really do some interesting stuff in a combination of things that I'm going to show you now. So when we are talking for automation, everything starts with the APIs. So I will start with the APIs. And in order to use the APIs, we need API endpoint. In our case, it is the NSX Manager. And the NSX Manager has different interfaces for, let's say, graphical interface, CLI, and also REST API interface. So based on this REST API interface, we can, currently this is what we do right now, integration with different platforms. So we are using different SDKs to write plugins for all these platforms. So we have integration with different OpenStack versions, and of course the best, the VMware integrated OpenStack. We have integration with Pivotal Cloud Foundry, with the Pivotal Container Service, and with many others, with Kubernetes. So this all interacts with the NSX APIs using different plugins. When we are talking for NSX T especially, you can use the language that you want, and we will provide you SDKs for this language. Actually, you will generate this SDK by your own, if it is different than the SDKs that we provide as a VMware supported solution. For NSX T, we have a Terraform provider, so you can use Terraform as well. and we are working on Ansible modules that can automate NSX T. And when we are talking for APIs, I will just quickly go through the main verbs. So you have post that creates an object. You also have get. It gets information for a particular object. We have put. This modifies information for a particular object. So you need to do get to obtain the information, and to do put to return back the modified version, and delete to delete this object. Also for the REST API, this is the URI. So we have the protocol, we have the API endpoint or the manager IP address, we have base path, and we have the specific resource that we want to manage. And yeah, this is an example for the JSON body. So you provide the information for the resource that you want to create, and it creates this, in this particular example, logical switch in NSX. For NSX T, the good point is that the API guide or all the API documentation is built in the NSX manager, and it is auto-generated, so there is no hidden APIs. Our approach with NSX T is APIs first. So when we produce something new, we expose the APIs, and the team that takes care for the user interface just consume these APIs. So it's a bit different than what we have now with NSX for vSphere. So all these are auto-generated, and you can see how you can access and see it. Also, we follow this open API standard. So together with the NSX manager and the API documentation, we provide the description of all APIs in a YAML or JSON format. And you can use different tools like Swagger CodeGen, for example, to generate the SDK or language bindings for the language that you want to use. And if you are using Python or Java, there is no need to do this. So we provide this as a VMware supported solution. I will quickly go to show you, if you are using Python, how easy it is to create resources. So you need to do, this is an example for, let's say, transport zone. You need to create a service. You need to fill the body of the transport zone that you want to create, and you need to pass this to the service in order to create the transport zone. Yeah, and if someone is interested, there is a blog describing more in details how you can do the rest of the things. So next section is for VRO, the vRealize orchestrator. I decided to go first with the APIs because yeah, it will be better, easier for me to explain how you can use these APIs in VRO in order to provide something that to automate NSX with something that is not natively built in vRealize automation. So there is add host by Swagger spec workflow in VRO. So you can use this, and you can specify the URL for the Open API specification, and VRO automatically will import all operations that we have available in NSX T as REST operations. After that, you can go and generate a workflow from this REST operation. So when you generate the workflow, you have something like this. The only problem here is that the content of the API code that VRO will do to NSX Manager is empty. So, but you will have this workflow generated, auto-generated, so you need to fill in the workflow. After that, when it is done, you can just expose this workflow to anything as a service blueprint in VRA. How it is so far? Is it too deep or? Okay. Okay, so this is what you need to do in order to automate something that is not available in VRA. With the version that we just announced of VRA 7.5, VRA supports natively NSX T. And of course, there is some pre-built logic in it, and I'm going to show you what exactly the logic is. In NSX T, we have two layers of routing, T0 router that is responsible for connectivity with the physical world, and T1 router that is a tenant router that is automatically provisioned from any automation management system. And when you create a blueprint in VRA, you can just drag and drop logical switches, load balancer, virtual machines, and this automatically will create a T1 router. We'll connect these logical switches to the T1 router, and we'll connect the T1 router to the T0 router. So you don't need to create NSX constructs other than logical switches. Everything will happen automatically for you. And once you create the blueprint, every time when the user requests new deployment, it will replicate this deployment. Okay. Something that is available as well in NSX for vSphere, we have it here. You can click on app isolation, and every new deployment will be completely isolated from the rest of the deployments. And this happens with dynamic security group. So it creates security group, and matching attack will add all these VMs in the security group. What we support now with VRA 7.5, we have day 1 and day 2 operations for NAT features. So when you deploy the blueprint, you can configure NAT. And as a day 2 operation, you can change this configuration if there is a need. Also, you can assign a specific existing security group to the workload that you create, to the virtual machines. And as a day 2 operations, you can change the security group. So this means you can deploy a virtual machine with specific firewall rules, and later at some point you can change this with different security group, different rules. For the load balancing feature, we have this for NSX for vSphere as well. Now we have it here. You can deploy an application with several virtual machines behind the load balancer as a pool members, and later you can scale out or scale in. So when you scale out, it automatically will deploy virtual machine and will add it into the load balancer pool. So you can scale your application that way. We have on-demand routed network, so you can deploy a network that the IP space of this network is advertised from NSX to the physical world, so the virtual machines will have direct connectivity. Also, you can deploy the virtual machines to existing pre-created logical networks. And yeah, as I already mentioned, the app isolation. So this is overall what we support with the first release of VRA 7.5 and NSX integration. How this happens? So we have VRA, and VRA do API calls to the NSX manager. The NSX manager configures the networking and security to the ESXi hypervisor. To be honest with you, because NSX T is, let's say, you can run it everywhere, we'll configure the same on a Linux KVM if you have such hypervisor as well. And after that, VRA will call the vCenter, and the vCenter will provision the virtual machine to the ESXi host, and will take care to connect it to the proper network. And if you want to build something more than VRA supports, of course, you need to use VRO. And VRA you will have the workflow exposed as a blueprint in VRA. So VRA will call the VRO, and VRO will execute this workflow and call NSX. Okay, I have one quick video just to show you how this integration looks like. So this one, here you can see I have vCenter with one empty cluster without virtual machines. In NSX for vSphere, the NSX configuration is inside the vCenter endpoint. Here, because NSX T is vCenter independent, we have two separate endpoints, NSX T endpoint and vCenter endpoint. When we go to the blueprint, so we can edit, so here I intentionally put just one virtual machine behind a load balancer with specific security group connected to a specific logical switch. And here we have NSX for vSphere and as well NSX T components. So this is the load balancer configuration. So yeah, when the user goes and requests a deployment from this blueprint, here in the first demo, I intentionally do just one instance of the virtual machine because I want to later show you how we can scale out. In NSX, in switching section, you see that we have 3 logical switches, and here we have just the default T0 router. This is the router that keeps the connectivity with the physical world. And still nothing configured here. So in the request, in VA Realize Automation, we can see where the request is. Right now, we can see that, okay, so it creates the logical switch. So there is no load balancer yet. Yeah, we need to wait a bit. Okay, so if we go back to the vCenter, it should start deploying the virtual machine because it created the resources in NSX. And when I click on the virtual machine, we will see that the virtual machine is connected to NSX T logical switch. And this, in this particular example, the vCenter doesn't have connectivity with NSX, so the vCenter learns these networks from the ESXi host itself. So the logical switch was automatically created by VRA with the name that I have specified, and this is the ID of the VRA deployment. All objects that are deployed based on this blueprint have an ID from VRA, and all these objects has NSX tag that you can easily search for everything that this particular deployment has created in NSX. So right now we have the T1 router automatically created here. And this is the tag that I was talking about. So if you get a call from the user, my deployment doesn't work, you can search in the UI and get everything that VRA was created with this, has created with this deployment. So if I go to the load balancer section, and if I click to the pool, so pool members, you will see I have just one virtual machine on the right side, just one virtual machine is a member of the pool for this deployment. So I will go in VRA and we will just scale out this deployment. So when I click scale out, I can specify how many VMs more I want to deploy. So I will say 2. And yeah, we are going through the same process to deploy one additional virtual machine, connect it to the logical switch here, and add it to the pool for the load balancing. Okay, so we had web 008, now we have 9 deployed. And if we click on the new virtual machine, we will see that this virtual machine is connected to the same logical switch. Yeah, so it is the same logical switch, and if we go to the NSX and if we refresh, we will see the new port for the new virtual machine is already connected to this logical switch. And if we wait a bit more, in order to have this virtual machine fully deployed and the application installed inside, we will see that this virtual machine has been added to the pool for load balancing. So this taking progress a bit longer, but I'm happy it is recording, and I know that it will be successful in a moment. Yeah, and actually this integration is available for you starting from today. Okay, and right now you see in the pool for the load balancing, we have 2 virtual machines. The new deployment is also here. So for the NSX T, what I would like to share with you that we have many lessons learned in the past with the previous NSX products. With NSX T, we have industry standard APIs, so you can use them with the language that you prefer. We have Python and Java SDKs. We have multiple automation tools like Terraform, Ansible, and last but not least, we have enterprise support for all this. And if you want to learn a bit more, here there are some more resources that after the session when we share the slides, you can just follow and learn more. Okay, and I think we are good. If there are some questions, we have enough time to answer them.
So I appreciate you guys walking through all this. It's really great. One of the things that can you speak a little bit to sort of the tearing down process? So in VRA with the expiration of the workloads and archiving and all that and tearing down. So we've got the create process in here, but what does it look like and what pitfalls have you guys experienced in that process of expiring those workloads?
Okay. I can share my experience because this lifecycle management is part of the CMBU. This is the team that looks after VRA. First, for scale out and scale in, so it's something well supported and maintained. For the archiving, so you can specify in the deployment itself how many days you want this to be available and when to be archived. I don't know if you have been any particular experience in your...
I think the challenge, of course, we faced was that because we didn't have the VRA piece available to us when we first went down this path, we have to kind of think, all right, okay, if I'm going to make something, I also need to make the method that's going to remove it. So you've got to think about these things up front. Anything that you create, you must create a method to destroy. Now with the added VRA functionality, that's going to make our lives a lot easier.
I don't know what kind of challenges you have, but with NSX T, we have something called search APIs. So based on the tags that the VRA deploys, you can search if there are resources with this VRA deployment ID. And for example, when your deployment is destroyed or archived, you can search if there is something left over or something.
I think the other thing to think about as well is with a classic firewall, you've got Panorama or you've got your Cisco devices. If you destroy servers, the rules stay there on the firewall and they're IP driven. If you're using security tags in NSX, you might create rules that are associated with tags, but if those tags aren't assigned to anything, they're not doing you any good. They're not harmful. So it is safe. You should be cleaning up after yourself, but it's less of a risk, I suppose.
And I was curious, if you're creating all of those NSX, networks and everything on the front end, what are the decision points in tearing down those networks? You may have dependencies in there for other workloads as some of those workloads are expiring. So I'm just curious.
We actually, our experience when we sat down, we actually had like a 2-week design session with the NSBU on how we wanted to approach NSX. We've come from a part of our company was financial services, and it was a very kind of overly complicated, highly regulated network environment. We'd built a lot of segmentation ourselves using things like VRFs, etc. The decision we took when we went to NSX was not to do on-demand switches, but to actually pretty much flatten out our networks. So when we stand up a private cloud instance, we put I want to say a /20 in there, he says looking. And then we use micro-segmentation to do everything. So it's a far flatter environment. But that sort of removes the challenges you have, particularly if you want to bring brownfield workloads into it. Yeah.
Yeah, so and in this particular example with the VRA takes care to remove the objects in the order that they need to be removed. So you cannot remove logical switch if you have virtual machines connected. So this will fail. So VRA takes this into account and remove the objects in the right order.
Yeah. I think to add just a little bit there, the other challenge we've got, most of our workloads weren't provisioned through VRA, and we want to bring them into this environment and leverage the advantages we get with NSX T and the Day2 Automation. So, again, that starts to inform your design choices. You have to think about it. If we were doing things in a greenfield scenario, yeah, it'd be lovely, but yeah.
First of all, thanks. Whoa.
Yeah.
First of all, thanks for this. This was great. I even enjoyed the API bits, so fantastic. Yeah. Also, demo with no custom forms? Come on, man.
So this is something that was released today. So you can imagine how much time I had to record the demo, right?
No, that's fantastic. So my question just kind of flows into everything looked great. How does this tie in with network profiles? I'm assuming it's basically a meld, right? But how does that really work with the NSX?
Yeah, so you mean with the reservation profiles? With the reservation?
Exactly, yeah.
Yeah, so it is very similar with what we have with NSX for vSphere. You create your reservation profile, you specify the subnet, and VRA will create IP pool in NSX T. So it's, the implementation is a bit different than NSX for vSphere, but the outcome is the same. So you specify the outcome, okay, yeah. So when you specify the network profile and you do the reservation, you have a drop-down menu to select the T0 router. So this is the upstream router where to connect these T1 routers. So this is where you specify all this configuration.
Okay, great.
The awesome thing there, though, because of the extensibility you get with VRO, is you can go down that road, or you could actually leap out something like Infoblocks and say,
yes,
okay, I want you to manage the IP address space, give me an IP.
Absolutely.
That's this subnet based off these tags.
And I really recommend you the session for our colleagues that are doing on Wednesday. So they actually take advantage for everything that I showed you, combination of it to do the automation, and they do really cool stuff, and they also do demo on all these things. So it will be a good session, I think.
The only other thing that I had is, you just pinned on it, was micro-segmentation. On the list of the built-in out-of-the-box ones, I didn't see that word there, but I assume it was there, just not, I don't know a ton about NSX.
No,
right?
Unfortunately, right now, in VRA, you can specify existing security groups. So if you have firewall rules, security groups pre-created, you can assign virtual machines to these pre-created rules. This is what we will support in this first version. So yeah, for more advanced firewall configuration, maybe you need to wait for the next version. I cannot commit for this, or to do. Yep.
Yep. This is the exact approach that we've taken. So every time we onboard a new product into private cloud, we build out the tags that relate to that product group, and that gets pushed into the NSX managers effectively. Probably overly simplifying things here, but yeah, so there's a lot of pre-creation of the tags, so when the product teams just want to spin stuff up, everything's there. Yeah.
Okay. Any questions, other? Okay then, thank you very much.
Yeah, fantastic.
Thanks.